Hello students, welcome to online classes. So I am Tirupati Reddy, chemistry lecturer. I am going to explain today solution and colligative properties. So for CET, NEET and JEE point of view, which topics are important? Let us see.
Single.
First to solution introduction, concentrations, terms of the solution, colligative properties, vapor pressure of a liquid, Raoult's law, ideal solutions, non-ideal solutions, azeotropic mixture, osmotic pressure, colligative properties of dilute solution. Next to reverse osmosis, isotonic solutions, colligative properties of electrolytes, and next to Wanda factor. Along with we have Henry's law also. Henry's law also there. Henry's law and its applications. Henry's law and its applications. In this session, I am going to explain. So first of all, let us see what is the solution. What is the definition of the solution? Let us see. What is the meaning of solution? Solution is a homogeneous mixture of solute and the substance that dissolves and a solvent. Actually, solution is a mixture of homogeneous mixture of the substances. So what is the meaning of the solution? Solution is homogeneous mixture of, it is homogeneous mixture of two or more substances. Two or more substances. In that substance, one substance is called as solute and another one is known as solvent. Actually, what is the definition of the solute? The substance that dissolves is known as solute, or we can tell solute is present in small quantity. Small quantity. Then it is the solute. What is the meaning of the solvent? The substance which is present in the large quantity is known as solvent. For example, if we take, so 2 moles of A dissolved in 5 moles of another substance, 5 moles of another substance. So then this 2 moles of A is known as solute because the quantity of the A substance is lower and the quantity of the B substance is higher. That is the reason it is called as solvent. Which is present in the lower quantity in terms of the number of moles, that is the solute, which is present in the higher quantity in terms of the moles, that is called as solvent. For suppose one more example, let us see. See, for example, 46 grams of ethyl alcohol. 46 grams of ethyl alcohol. Molecular weight is how much? 46 grams. Dissolved in 90 grams of water. Then which is the solvent and which is the solute? Let us see. 46 grams of ethyl alcohol. To get the number of moles, what the formula we are using? 46 divided by 46 is equal to 1 mole we will get. Next one. So to get the number of moles of water, how much we will get the number of moles of water? Number of moles of water is equal to 90 divided by what is the molecular weight of the water? 18. 90 by 18 is equal to how much we'll get here? 5 moles. So in this condition, which is having less amount in terms of the moles. So here ethyl alcohol is having less number of moles, therefore it is called as solute. And next one, water is there now, that is known as the solvent. It is the introduction of the solute and solvent. Here they given the component of solution which is lesser amount, which is present in the lesser amount, that is called solute. The component of solution which is present in the higher amount, that is called as solvent. Next one, so concentration of the solution, let us see. To express the concentration of solution, we have different terms. Let us see the terms one by one. The concentration of solution can be expressed in different ways, like molarity, molality, mole fraction, normality, mass percentage, volume percentage. So different ways of expression. ppm, parts per million, also there. See, first one, molarity. Let us see what is the molarity and what formulas we are using in molarity. Let us see. What is the definition of the molarity? The number of moles of solute in 1 liter of solution is known as molarity. Number of moles of solute in 1 liter of solution is called as molarity. Number of moles of solute present in 1 liter of the solution. Molarity is equal to number of moles of solute by volume of solution in liters. Molarity is expressed by, so capital M, after the number of, for example, X indicates, X means X molar is there, they given, for example, X molar is given. X molar indicates what, X moles of solute present in the 1 liter of the solution. For suppose they given 2 molar, they given 2 molar, what it is represent? 2 moles of substance, 2 moles of solute present in how many liters? 1 liter. 1 liter. For example, 10 molar they given. 10 molar indicates what? 10 moles in 1 liter of the solution. 1 liter. To calculate the number of moles, what formula we have? Number of moles to get gram divided by molecular weight we are using. Gram molecular weight. So it is the number of total number of moles, how we can get it. We should be careful about the unit of the volume taken. We have to use volume in liter in the formula for molarity. So if volume is given in milliliters, the formula will be changed. Actually, volume in liters, if you want to get volume in milliliter into, we have to take the 10 power minus 3. See, here, for example, 1 ml they given, 1 ml they given. How we can convert it into liters? 1 into 10 power minus 3 liters. Like that we can convert. So what are the units of the molarity? Molarity units. Unit of molarity, mole by liter. Mole by liter is the unity. Molarity is equal to N by V formula we are using. Number of moles by volume in liters. So molarity is equal to number of moles we can get by weight by gram molecular weight into 1 by V in liters. So for example, volume they given in milliliters. What is the formula we are using? Weight by gram molecular weight into 1000 by V volume we are using in milliliters. Next one, for example, they given molarity they given, volume they given. Then how we can get the number of moles? How we can calculate the number of moles? Molarity is equal to N by V. From this we can get a molarity, number of moles is equal to molarity into volume we can get. Like this we can calculate the number of moles. So here volume should be in liters only. Always we have to use the volume in liters. For example, if you wanted to get millimoles, then what formula we have to use here? Molarity into volume in milliliters we need to use. Here the strength of the solution is equal to weight of the solute into 100 by volume of the solution in milliliters. If we use this formula, we can get what? Strength of the solution. Weight of the solute into 1000 divided by volume of the solution in milliliters. Molarity is temperature dependent unit. It is depends on the temperature. If temperature changes, molarity also changes. So how it is related with the molarity? Molarity is related with the temperature. Molarity is inversely proportional to the temperature. So this is related with total molarity. Next one, in this molarity, some other formulas also we can use, like on dilution condition, what formula we have to use here? M1 V1 is equal to M2 V2 formula we can use on dilution condition. Molarity of the mixture also we can use. What formula? Molarity of mixture. This is the formula we can use for molarity of the mixture. Molarity of mixture is equal to what is the formula? M1 V1 plus M2 V2 by V1 plus V2 formula we can use. So this formula when we can use, if same type of solutes are there, same type of solutes. For example, acid and base, acid plus acid mixed, not base, acid and acid mixed, then we can use this formula to get the molarity of the mixture. Next, per suppose acid and base are mixed, acid plus base mixed, then which formula we have to use to get the molarity of the solution? So for example, we are calculated MAVA, it is greater than MBVB, then what formula we have to use in this condition? Molarity of the mixture is equal to MAVA minus MBVB divided by VA plus VB formula we can use. That is a formula for molarity of the mixture. For suppose we calculated MAVB, number of moles of the base we calculated, it is greater than the number of moles of the acid. So whenever MBVB is greater than MAVA, to get the molarity of the mixture, then what formula we can use? Molarity is equal to MBVB minus MAVA divided by VA plus VB formula we can use to get it. So it is about the different types of formulas. Next, one more formula is there, important formula. For suppose they given in the question they given X percentage they given. X percentage weight by volume percentage they given, density they mentioned, and they asked to calculate the molarity. Then what formula we can use? Molarity is equal to X percentage into 10 into density divided by gram molecular weight formula we can use to get the molarity of the solution. If we get molarity is equal to 1, it is 1 molar solution. For example, the molarity is equal to 0.1. it is known as decimolar solution. Decimolar solution. Our answer is 1, the molar solution it is called. If we get the molarity is equal to 0.1, that is called decimolar solution. If we get molarity 0.0001, then it is called as centimolar solution. If we get molarity is equal to 0.001, it is nothing but 10 power minus 3 molar, then it is called as millimolar solution. Millimolar solution. For example, if we get the molarity 1 by 2 is nothing but 0.5 molar, that is called as semimolar solution. Semimolar. Molar solution, decimolar solution, centimolar solution, and next one millimolar solution. Like that we can differentiate. The next one, let us see one more concentration term, that is molality. Let us see the molality. So, well, molality is very simple molality. What is the molality? The number of moles of solute per kilogram of solvent. What is the definition of the molality? The number of moles of solute present in 1 kilogram of the solvent. If you take 1 kilogram of solvent, how many moles are present? How many moles of solvent present? That is called as molarity. And what is the unit of the molarity? Mole by kg is the unit of molarity. Sometimes mass of solution is given instead of solvent. So subtract the mass of the solute to get the mass of the solvent. Okay, here it is the important point. Once I want to explain you regarding this. So this is the important point. Sometimes in the question, so what they will provide, they are going to provide only mass of the solution they provide. Sometimes mass of solution is given instead of the solvent. Mass, total mass is equal to the given, for example, total mass is equal to 150 grams. 150 grams. Total mass of solution equal to 150 grams. Next one. So mass of solute is equal to the given how much 50 grams. Then what is the mass of the solvent? Solvent mass is equal to how much it is? Solvent mass is equal to 150 minus 50, that is equal to 100 gram is the answer. So compulsory in this formula what we have to use, mass of the solvent we have to use in only kilograms. So this molality is represented with the suffix m after x number. X, for example, here one m they given, one small m they given. What it is indicates? It indicates 1 mole of the solute present in 1 mole present in 1 kg of the solvent. That is the meaning of the 1m. For example, 0.5 m they given. What it is represent? 0.5 moles present in 1 kg of the solvent. Here, molality does not change with the increasing temperature. It is temperature independent. It does not depend on the temperature. And there is one important relation between molality and molarity. Molality is equal to 1000 into molarity, 1000 into density minus molarity into molecular weight of the substance. So this is what molecular weight here, molarity. So they are going to ask the question on it. Next one. So let us see next topic, mole fraction. What is the mole fraction? One more concentration term. Let us see mole fraction. Mole fraction, what is the definition of the mole fraction? Mole fraction of a compound in a solution is equal to the ratio of number of moles of that component and total moles of all components. So that is the definition of the mole fraction. Here, what is the definition of the mole fraction? Mole fraction is a ratio between number of moles of one component to the total number of moles of all components. If a solution is made up of only two components like A and B, then mole fraction of A, how we can calculate? Na by Na plus Nb. Mole fraction of B, how we can calculate? Nb by Na plus Nb. By using this formula, we can calculate. See, sum of the mole fraction of all components in the solution is always equal to what? Equal to 1. Okay. So this is the formula, and here we have first component mole fraction, how we can calculate like this. Second component mole fraction, by using this formula we can calculate. So if you want to get the number of moles of first component, for suppose in the question they given weight of that substance, then what formula we have to use? So number of moles of A component is equal to weight of that component and upon molar mass of that component. So important point is, it is a temperature independent unit. It does not depends on the temperature. And there is a relation between mole fraction as well as mole fraction and molarity also there. Here I written mole fraction of the first component and mole fraction of the second component. By using this we can calculate the mole fractions. Next, let us go for so here mole fraction of the solute, if you want to get XA is equal to Na by Na plus Nb. If we take the ratio of these two, XA by XB is equal to what we will get here? Na by Nb we will get. On multiplying 1000 in both sides, XA by XB into 1000 is equal to 1000 into Na by Nb. XA by XB is equal to, here we can write one important point here. What is that? Here actually this formula, in this formula, XA by XB is equal to, so here we have the formula, important formula, Na by yes, here we have XA by XB is equal to 1000 by molarity into molar mass. So this is the relation between molarity as well as mole fraction. It is the relationship. Next one, mass fraction. What is the mass fraction? Let us see. Mass fraction, it is a ratio of one component to the total mass of all component. Whenever we take the ratio of one component to the mass of total components, that is called as mass fraction. Here mass fraction of A is equal to what formula we can use? Weight of the first component by total mass of the components we can use. WA is equal to weight of first component. WB is equal to weight of the second component we can use. Here it is the important formula, mole percent. To get the mole percent, what formula we can use? So to get the mole percent, number of moles of a component in 100 moles. So that is equal to mole percentage. Mole percentage is equal to mass fraction into 100. So it is one more important relationship. So this is parts per million. Parts per million, when we will use, whenever trace quantity, if the solute is present in trace quantity, then we will use parts per million. What is the meaning of the parts per million? The number of parts of one substance present in 1 million parts of solution is known as parts per million. To get the parts per million, mass of the solute divided by mass of the solution into 10 power 6 we can use. Here ppm is equal to weight of the solute by weight of the solute plus weight of solvent into 10 power 6. So this generally it is used for very little concentrations, like to express the uh, environmental pollution. Generally we are using parts per million. Along with this concentration terms, one more concentration term is there, that is normality. What is the meaning of normality? Let us see. What is the normality? Let us see now. Normality means what? The number of moles of substance present in, number of gram equivalents of substance present in. Here, number of gram equivalents of solute present in 1 liter of the solution is known as normality of the solution. What is the unit of this one? Gram equivalents per liter. So what is the unit of normality? Gram equivalents per liter is the unit of normality. To calculate normality, what formula we have to use to calculate the normality? This formula, gram equivalent of solute by volume of the solution in liters we can use. See, normality is equal to one more formula here. Normality is equal to, what is the formula? Gram equivalents of solute, gram equivalents of solute divided by volume of solution in liters we can use liters. Next one, normality is equal to get the gram equivalents, what formula? Weight by gram equivalent weight into 1 by V formula we can use. Gram equivalent weight. So what is the gram equivalent weight? Gram equivalent weight means what? The amount of substance that can combine with 8 grams of oxygen or 35.5 grams of chlorine or 23 grams of the sodium or 1 gram of the hydrogen is known as gram equivalent of the substance. What is the gram equivalent of the substance? The amount of or the parts of the substance that can combine with 8 parts of oxygen or 35.5 parts of the chlorine, next to 23 parts of the sodium or 1 part of the hydrogen is known as gram equivalent weight. So actually gram equivalent weight, if you want to get different formulas, we can use gram equivalent weight. For suppose gram equivalent weight of acids, if you want to get, what formula we can use? Molecularity divided by molecular weight divided by, so we can use the basicity to get it gram equivalent weight, we can use that formula. In case of bases, what formula we have to use? What is the formula we can use in case of bases? To get the gram equivalent weight of the base, we can use this formula. Gram equivalent weight is equal to molecular weight divided by acidity we can use. Okay, so different formulas are there related to gram equivalent weight. Now equivalent, to calculate number of equivalents, what the formula we can use here? Actually in the previous means molarity we discussed what is the how we can calculate the number of moles. To get the number of moles, molarity into volume we can use. Similarly, to get the number of equivalents, what formula we can use? Normality into volume we can use. This is the formula we can use. Next one. So after that, here weight of the solute and equivalent weight of the solute also we can use. To get the number of equivalents, weight of the solute by equivalent weight of the solute we can use. Here milli equivalents, if you want to get normality into volume in milliliters we have to use. Here milli equivalents if you wanted to get weight of the solute by equivalent weight of the solute into 1000, different types of formulas we have to get it. So this is one more important formula. See, for suppose they given specific gravity or density they given, then which formula we can use? This is the formula we will use to get the normality. 10 into specific gravity or density and weight percentage of solute divided by gram equivalent weight of the solute. So they given, for example, percentage, X percentage they given, and the density mentioned, and they given some substance. If we know the gram equivalent of that substance, we can calculate normality. Normality is equal to X percentage into 10 into density divided by gram equivalent weight. It is the formula we are using to calculate so normality of the substance. And strength of solution, if you want to express, so this is the formula we are using. Strength of solution gram per liter. So it is the formula we are using. Normality into gram equivalent weight of solute. So if we use, we can get what? Strength of solution equal to normality into equivalent weight. How? Actually, normality is nothing but weight by gram equivalent weight into, so 1 by volume in liters into here gram equivalent weight is there. This gram equivalent weight and gram equivalent weight get cancelled. The final answer is what? Weight by volume. Weight by volume is nothing but strength of solution. Strength of the solution only. Normality is a temperature dependent quantity. It is depends on the temperature. So to get the concentration in grams per liter, what formula we can use? Equivalent weight into normality we can use. And here the relation is there in between normality and molarity. There is a relation. So what is that relation? Normality is equal to molarity into valency factor is the relation. It is the relation we are using to get the normality. Next, this is related to total normality. And let us go for the next one. Yes. Colligative properties. What are colligative properties? Let us see. Colligative properties. So certain properties of dilute solution containing non-volatile solute does not depends on the nature of solute. They depends on the only number of particles. That type of particles, that type of properties are known as colligative properties. What are colligative properties? Colligative properties means what? Properties of the system that depends on only number of particles and they does not depends on the nature of solute particles. They are called colligative properties. Here we have colligative properties like lowering of vapor pressure of the solvent, osmotic pressure, elevation in boiling point, depression in freezing point. So next to lowering of vapor pressure, RLVP, relative lowering of vapor pressure. So these are an examples of what? So colligative properties. Next here, vapor pressure of the liquid. What is the vapor pressure of liquid? Let us see now. Vapor pressure of liquid. What is the definition of the vapor pressure of liquid? Let us see now. It is the pressure that its vapors exert when in equilibrium with the liquid at a given temperature. What is the vapor pressure? See, here we take one volatile substance. Volatile substance is taken in a beaker and it is the closed beaker. It is liquid, volatile liquid like ether we can use. So what happened? This layer, upper layer is having unbalanced force of attraction. That is the reason what happens, it undergo evaporation. Like this, it undergo evaporation. They escape from the liquid and they converted into vapor. That phenomena is known as evaporation. Next, after some time, this vapor molecules again come back to the on the surface of the liquid. That is called as condensation. So, in case of this reaction, for example, if the temperature is constant, after some time, what happens? So, there is a equilibrium between rate of evaporation and rate of condensation. Rate of condensation. Equilibrium is established in between evaporation and condensation. At that condition, rate of evaporation and rate of condensation both are become equal. So, at that condition, the pressure exerted by the vapor on the surface of the liquid is known as vapor pressure. At equilibrium condition, how much of pressure they are going to exert on the surface of the liquid, that is called as vapor pressure. Vapor pressure is depends on the nature of solvent and temperature and percentage of purity, surface area, like this. So it depends on some characters. Nature of solvent. Some solvents have high vapor pressure. Which are having high vapor pressure? Easily volatile. Volatile substances have high vapor pressure. Volatile substances. Temperature. So if the temperature increases, what happens? Vapor pressure increases. Directly proportional. Vapor pressure and temperature directly proportional increases. So here this is related to totally vapor pressure of the solution. The next one, let us see the Raoult's law. What is the Raoult's law? What it is explaining? Let us see. According to Raoult's law, at given temperature, the vapor pressure of a solvent in a solution So what is the Raoult's law? Raoult's law proposed the law, what it is going to represent. Yes. So according to Raoult's law, the vapor pressure of the solution pressure is directly proportional to mole fraction of the solvent. According to Raoult's law, vapor pressure of substance is directly proportional to mole fraction of the solvent. P is directly proportional to X1. So P1 is directly proportional to X1. P1 is equal to P1 naught into X1. Similarly, P2 is equal to P2 naught into X2 we can write. The total pressure exerted is equal to PT equal to P1 naught X1 plus P2 naught X2. It is the formula we are using to get the total pressure. Total pressure. Here X1 and X2 mole fraction. Mole fraction X1 is the mole fraction of solute and X2 is the mole fraction of the solvent. P1 naught and P2 naught are vapor pressures in pure state, pure form, vapor state. See, to get the mole, here one more formula is there. For example, partial pressure of A is equal to, or what substance 1 is equal to. So what formula we can use? Its mole fraction into total pressure we can use. Similarly, P2 is equal to, we can use X2 into total pressure we can use. To get the vapor pressure or partial pressure of first component, mole fraction of first component into total pressure. Mole fraction of second component is equal to X2 into total pressure we can use. So these are the formulas. And here, how we will get the graph, and let us see the graph also. For example, whenever we plot a graph in between pressure versus mole fraction, how we will get the graph? See, like this we will get the graph. XA is equal to 1, XB is equal to 0. So first component, totally only first component is there, second component is equal to 0. Then how we are going to get the graph here? Like this we will get the graph. This kind of graph we are going to get. Here this is related to first component PA. And whenever XA is equal to 1, XB is equal to 0, then it is equal to PA naught, vapor pressure in pure state, PA naught. Next one, XB is equal to, for example here XA, X1 is equal to decreasing, XA is equal to 0 and XB is equal to 1. So slowly decreasing. Whenever the mole fraction of second component is decreasing, then how second component is increasing and first component is decreasing, how we will get the graph? Like this we will get the graph. This is the vapor pressure of the B component, second component, and it is indicates total pressure PT. Actually, which solutions obeys Raoult's law? They are known as ideal solution. What are ideal solution? Which obeys Raoult's law? They are called as ideal solution. So in case of ideal solution, P total is equal to PA naught XA plus PB naught XB we can write ideal solution. Which are examples for the ideal solution and the non-ideal solution? Let us see here. Ideal solution means they are going to follow Raoult's law. Example for ideal solution, we have, these are an examples of the ideal solution. hexane plus heptane, ethyl chloride, ethyl bromide, chlorobenzene, bromobenzene. These are an examples of the ideal solution. In case of ideal solution, enthalpy mixing delta H mix is equal to 0 and delta V mix also equal to 0 in case of ideal solution. What are non-ideal solutions? Which does not obey Raoult's law? The solutions which does not obey Raoult's law, they are known as non-ideal solution. In case of non-ideal solution, delta H mix is not equal to 0, delta V mix also not equal to 0. These non-ideal solutions are going to show two types of deviations. They are positive deviation and a negative deviation. See, they are going to show two types of deviation, positive and a negative deviation. So first one, positive deviation. Whenever they are going to show the positive deviation, for example, here A solvent is there and B solvent is there. A solvent has which type of interactions? A type of interactions. A. If we take B, B has which kind of interactions? BB type of interactions. A has A type of interactions, B has BB type of interactions. If we mix these two and if we prepare one solution, so this one has AB type of interactions. There are AB kind of interactions. If these interactions are weak compared to AA and BB interactions, so then the produced solution is going to show positive deviation from the Raoult's law. Whenever whenever one solution is prepared from two components, here the interactions are weak, then it is going to show positive deviation. In case of positive deviation, how we will get the graph? Like this we will get the graph. Just now we discussed about the graph now. Like this we are going to get. For example, in case of ideal solution, we will get the graph like this. But if there is a deviation, positive deviation, then it is going to show like this kind of graph. This kind of graph only we will get. That is a positive deviation. Which solutions are going to show positive deviation? Acetone plus ethyl alcohol, water plus ethyl alcohol, carbon tetrachloride, ethanol. So these are going to show a positive deviation from the Raoult's law. Next one, negative deviation from Raoult's law. Which are going to show negative deviation from Raoult's law? Actually, if there is a negative deviation, so compulsory A-B interactions must be strong compared with AA interactions. Comparatively, AA-BB interactions, AB interactions are strong, then it is going to produce what? A negative deviation solution. Now, in this solution, how we will get the graph? Like this, we are going to get the graph. Like this, negative deviation, vapor pressure, because of strong interactions, vapor pressure is going to decrease. So that is the reason we are going to get the graph like this graph we will get. Next one, example for solution which shows negative deviation. Which are the example for solutions which shows negative deviation? The mixture of acetone, aniline, HCl plus water, HNO3 plus water, water plus H2SO4. These are going to show negative deviation from the Raoult's law. Next one. So this is the important topic, azeotropic mixture. What is the azeotropic mixture? Let us see. Azeotropic mixture means For example, one solution we prepared. By combining A and B, we prepared one solution. So this solution can be separated by using some methods like distillation, fractional distillation we can use to separate. But if we some solutions if we prepare, we can't separate with the help of fractional distillation. Such type of mixtures are called as azeotropic mixtures. So azeotropic mixtures we cannot separate by using fractional distillation. What is the reason for it? Reason is they have same composition in liquid phase as well as in vapor phase. So we cannot separate azeotropic mixtures even by distillation, fractional distillation also. The reason is they have same composition in both liquid phase and vapor phase. Here azeotropic mixtures are how many types? There are two types of azeotropic mixtures. Minimum boiling azeotropic mixtures and maximum boiling azeotropic mixtures. So see what are minimum boiling azeotropic mixture and maximum boiling azeotropic mixture. Mixture of two liquids whose boiling points are less than the two pure components, they are formed by the non-ideal solution showing positive deviation. So for example, ethanol plus water, by this ratio if we are going to mix 95% of ethanol and 4.5% of water, that leads to formation of the minimum boiling azeotropic mixture. In this condition, minimum boiling azeotropic mixture, boiling point is going to reduces because vapor pressure is high compared with the relatively vapor pressure what happens increases. So that is the reason boiling point what happens in case of positive deviation reduces, decreases. Maximum boiling azeotropes. So what are maximum boiling azeotropes? These are the mixtures whose boiling points are more than the either two components. They are formed by the non-ideal solution showing negative deviation. Example for it, HNO3 plus water. HNO3 and water are an examples of this kind of solutions. So it is about the azeotropic mixture. The next one, osmotic pressure. Let us see what is the osmotic pressure and what are the formulas we are using. So first one, osmosis means what? Osmosis means what is the osmosis? Osmosis. So when a dilute solution and concentrated solution separated through semi-permeable membrane, like this, semi-permeable membrane is the semi-permeable membrane SPM. Through semi-permeable membrane, dilute solution, and also concentrated, highly concentrated solution, so separated, then what happens? The movement of the molecules takes place. Which molecules? Solvent molecules takes place from dilute solution to highly concentrated solution or concentrated solution through a semi-permeable membrane. This phenomena, this spontaneous phenomena is known as osmosis. Osmosis. What is the osmotic pressure? Osmotic pressure is a colligative property. What is the osmotic pressure? To stop the osmosis, we need to apply some pressure on the solution. Here it is a dilute solution, it is concentrated solution. If you want to stop the osmosis, we need to apply some pressure, extra pressure on the solution. That pressure is called as osmotic pressure. Osmotic pressure it is. Osmotic pressure is a colligative property. Next here, to calculate osmotic pressure is denoted with pi, and what formula we are using to calculate the osmotic pressure? Pi is equal to CRT. This is the formula we are using. Pi is equal to CRT. Means it is C for concentration molarity, R is universal gas constant, T is the absolute temperature. Next here, one more important point is there, isotonic solutions. Isotonic solutions. What are isotonic solutions? The solutions whose osmotic pressure is, whose pi is same, they are known as isotonic solutions. Actually, what formula we can use to get the osmotic pressure? Pi is equal to CRT formula we are using to get the osmotic pressure. Whenever osmotic pressure is same, then we can write pi 1 is equal to C1 or T1. Pi 2 is equal to C2 or T2 we can write. So if pi 1 is equal to pi 2, then C1 or T1 is equal to C2 or T2 we can use. This is the formula. It is the formula. Next, after this, so and we have one more qualitative property, that is elevation of boiling point. Elevation of boiling point and depression of the freezing point. Elevation of boiling point. In elevation of boiling point, what formula we can use? Delta TB is equal to TB minus TB naught. TB minus TB naught. Delta TB is equal to TB minus TB naught we can use. Delta TB is equal to KB into molality. This formula we can use. KB into molality. Here, in case of elevation boiling point, here I written elevation in boiling point delta TB is equal to KB into M. KB into, in place